Hello and welcome. My name is Erik Anderson, the owner of Scopos and our Chief Architect. And today we are going to run through a video titled The Technical Introduction to Reconfigurable Rulebook Definition Files. The purpose of this video, the audience of this video, are two groups of people. One, please note that this is a technical introduction, so it is intended for programmers or at the very least technical officers. Programmers may want to learn about our definition files for accessing our Scopos data using our REST API or Babelfish, our NuGet library. Technical officers at local and regional clubs may want to learn how to compose their own definition files and get a better understanding of what they are and how to use them. Please also note that this is an introduction. It's not meant to be a deep dive, but rather to get everybody's feet wet and get you started. All right, so let's ask the obvious question: what is the Reconfigurable Rulebook? At its core, the Reconfigurable Rulebook is a way of formatting data for the sport of shooting, with the goal of taking the concepts and rules found in a printed rulebook and writing them into a standardized form that computers can readily understand. All right, so what does that mean in practice? The Reconfigurable Rulebook allows us to separate the rules that we find in a printed rulebook from the software implementation. The rules that we know from a printed rulebook are written into a standardized JSON formatted definition files. And because they're standardized, computers can understand them. And we have, of course, documented what that format looks like. And then the software system just has to implement what we call a rulebook engine to interpret these definition files and act on them. So again, we are separating the concepts of a printed rulebook. We're putting those into a definition file, and we are also, have this idea of a rulebook engine that is completely separate. And this allows us to write the rulebook engine in a way that we don't care if we're running a CMP match. We don't care if we're running a USA shooting match. We're just implementing the engine. Makes for incredibly fast development once the engine is put together. So taken together, the concepts that we understand within a printed rulebook come from both the definition files and the rulebook engine. All right, where to get the definition files? We make the definition files available on our publicly available REST API, which is also available through our Babelfish NuGet package. And we're going to demonstrate how to access the definition files in a demonstration at the end of this video. They are publicly available, and we encourage developers worldwide to access them. All right, so let's take a hopefully understandable example of a definition file and how this maps to a printed rulebook. And the example that we have in front of us is a tie-breaking rule. How to rank competitors in a match. So again, the printed rulebooks are going to have a set of English words on what the tie-breaking rules are, and what we want to do is convert those those sentences in the printed rulebook into something that a computer can understand. So in this example, we have the air rifle rules for ranking from the CMP Airgun rules, and they read: ties will be broken according to the highest score in the last 10-shot series, then by the next to last series, and if a tie remains unbroken, scores will be compared on a shot-by-shot basis, beginning with the last shot, then next to the last shot, etc. All right, so that's what the printed rulebook says. And the way that we interpret this within a definition file is as follows. It's on the right-hand side of the screen. First is JSON. Second, near the top, we have a unique identifier for this set of rules. If you want to know Orion, generic decimal standing. It is of a type ranking rule. And the rules say, there's three of them listed. The first one says we are going to sort competitors in descending order. We're going to use the event called standing, and we're going to use the score from standing, and specifically we're going to use the D, which is short for decimal score. So rank everybody by their aggregate score using decimal scoring. And then if the tie remains, we go on a 10-shot series count back. And this second set of rules is actually 6 rules in one. You'll notice that the values say 6.1. So 6, then 5, then 4. And it's very similar. We're going to sort them in descending order. And the event name is now ST, and the squiggly lines are a wildcard. So we're first going to replace them with ST6, then ST5, ST4, and so on. And again, we're going to use the score component and the decimal score component, the D, specifically. So again, this is the 10-shot series count back. Then again, if the tie is still unbroken, we go on a shot-by-shot count back. And again, this is that last JSON object there is actually 60 rules in one. That's 68.1. Again, it's similar. We're going to go in descending order. The event names, each shot has its unique event name. It's S60, then S59, then S58, etc. And again, we're going to take the score and the decimal portion of the score. So again, here we have the concept from a printed rulebook, and we've put it into a JSON definition file that a computer can understand. All right, there are currently 10 different definition types, definition files defined. And again, because this is an introduction, I don't have time to go into a deep dive on all of these. Hopefully, again, you'll get an appreciation for the different types of definition files, however. At the top, we have event styles and stage styles. Event styles define a type of shooting. And an easy example that a lot of people here in the United States understand is 3-position sport or air rifle. That is a type of shooting. The stage style kind of breaks the event style up into its components. And stage styles always have the, fired in the same position, using the same equipment class, the same time limits, distance of fire, etc. So again, using the 3-position sport or air rifle example, we would define 3 different stage styles. Sport or air rifle kneeling, sport or air rifle prone, sport or air rifle standing. A attribute is something that describes a participant in a match. Again, using the 3-position air rifle example, we could define an attribute, and we could define an attribute that says if a athlete is shooting sporter or in the precision class. Course of fire is the largest and most complex of the different definition types, and we're going to have a little bit of deep dive in a moment about a course of fire. But it defines everything from the event structure to literally the commands that the chief range officer gives, as well as things like the height of a ESD target, if the lights are on and off, how scores are displayed, etc. Event and stage style mapping kind of combines everything that we've covered so far. And so when an athlete participates in a match, we want to be able to say that they're shooting sport or air rifle. And the event and stage style mapping defines how to map an athlete, depending on their attributes, to the stage styles. All right. A target, as you might guess, is the definition of the scoring rings that athletes fire at, as well as the colors and shapes of that target. We have already predefined, at least as far as we can tell, all of the major targets that the major governing bodies here in the United States use. Target collection is a set of targets that are used within a course of fire. This often comes up in pistol shooting. Often in rifle shooting, there's only one target used throughout the course of fire. In pistol, there's often multiple. Easy example to understand is like within bullseye pistol, we have both a 25 yard target and a 50 yard target. And same way with like indoor, we have a target for timed and rapid fire, and we have a time for slow fire. That's a target collection. Then the final three sets all pertain to results and how to display them. Ranking rules. We just had an example of a ranking rule to define how participants get sorted, get ranked within a match. The score format collection related defines how to display the scores that a athlete or team shoots. We have different definitions for if you're ranking athletes by integer scoring or by decimal scoring. And then finally, the result list format defines how to display a result list. And this is actually really neat because you can define different ways of displaying the same results, whether you're on a mobile view or a large screen view or PDF or what have you. That is result list format. All right, set names. How to identify a definition file. Again, definition files are uniquely identified by their set name. More specifically, they're identified by their definition type and their set name. So example here, we're going to use a definition type of course of fire. And we could have a set name called V1.0 Orion 3-position air rifle 3x10. That's our unique set name for this definition file. The V1.0, that is the version number. Definition files do have versions, and you basically expected that at some point you'll be updating them. And so we have major and minor versions of definition files. Major versions largely refer to major revisions of a printed rulebook. Minor versions usually refer to, basically bug fixes. Maybe you didn't have the correct range command listed. Maybe you had a time that was off. So you make minor versions that are, again, not referencing a different edition of the rulebook, but just small changes that need to be corrected. And we have a notion of, in this example, V1.0. That .0 means give me the latest minor version within that major version. So what that means is you don't have to worry about trying to figure out what the latest minor version is. That 1.0, that .0 notation always gives you the latest minor version. So namespaces have the version and then a namespace. And the namespace refers to the organization that wrote and owns the definition file. Here at Scopos, we use our namespace Orion, referencing our flagship bench management system, as our namespace. And then different organizations would have their own namespace. And then finally is the proper name. 3-position air rifle 3x10. This proper name is meant to be semi-human readable and is usually prefaced by the subdiscipline. So in this case, 3-position air rifle is the subdiscipline, and 3x10 would be the course of fire. Human readable course of fire, I should say. All right, where to find definition files? One, within Orion itself, when we install Orion, each version has a copy of the latest set of definition files, and that gets saved to your hard drive, and it's found in the My Matches database definitions folder. Second, you can access all of the definition files using our REST API, and we have Postman examples on how to do so, and we have the URIs to access the definition files here as well, listed on this screen. But most people Most programmers are going to get a copy of the definition files using Babelfish, our NuGet .NET NuGet package. This is the easiest way to get to get access to the definition files. Within Babelfish, there are two different mechanisms to access the definition files. The one that is preferred and the one that we here at Scopos almost exclusively use is called the definition cache. It has, as the name implies, a lot of caching mechanisms to make the lookups fast and easy. Again, that's the preferred method. If you like things a bit lower level, there's also the definition API client class to also access the definition files. Accessing the definition files, whether you're doing it through the REST API or through Babelfish, does require a XAPI key. If you are a Orion for Clubs customer, you may have one for free. The XAPI keys for existing Orion for Club customers are limited, but they're kind of intended for your club's personal use, such as if you want to come up with a website of your own using Scopus data to display results. That's what the XAPI key is limited to, that type of use. If you're a personal developer, perhaps even a student, we will give you access to XAPI key for free. Again, they're limited in use and they're limited in duration. And then the final category is for application developers. You may purchase a XAPI key, one per application. Currently, the XAPI keys for application development are free. However, we are planning to start charging for use of the XAPI keys probably in the year 2027, but currently they are free to use. Documentation. We have complete documentation, the formatting of each of the definition files on our website, support.scopus.tech. And we also have documentation within the NuGet package documentation found at babelfish.scopus.tech. All right, so let's take a look at one of the definition types, the most complicated one, and see what's behind it. So we're going to look at the course of fire definition type. A course of fire basically defines the complete structure of a competition. Everything from each event, the aggregate event, the stage events, the strings, the series, all the way down to each shot. It precisely defines each of these events within the match. And then it provides references to the recommended ranking rules, how athletes should be ranked within this match, as well as recommendations on how they should be displayed online, on the phone, or on a PDF. We also provide, the course of fire also provides default mapping to event and stage style. So again, going back to the example, if you're an athlete shooting in the sporter class, how does that get mapped to the sporter air rifle prone, sporter air rifle standing, sporter air rifle kneeling stage styles? And then, of course, it provides the range scripts. We'll talk about this more in a few slides, but again, these are everything from the literal commands that the range officer says to the athletes. It also includes the time limits for each stage of the event, and things such as, are the ESD lights on or off? What are the height of the targets? So within a course of fire, I mentioned that we define each event within the course. And the event is everything from the aggregate, in this example, we call it qualification, to the stages of the event, kneeling, prone, and standing. Then that again gets broken down into the strings. Kneeling has 2 strings in a 3x20. Kneeling 1, kneeling 2, prone has 2, standing has 2. And then we go even further and define each shot within the 3x20. And this collectively is what we call the event tree. And then finally, the course of fire also defines a range script. In the course of fire, we can have multiple range scripts. For example, you can have one range script specific for shooting on paper targets. You might have another for shooting specifically on ESTs. Each range script will have, divided up, each range script will have multiple segment groups, and each segment group has a set of commands and a set of segments. A command is something controlled by the range officer. The range officer literally is the one advancing through the commands. And they contains things such as, again, the literal command that the range officer says to the athletes. It says things about the time limits, when to start the clock, when to stop it, and also has some automation built in as well. And then segments, the key difference between command and a segment is a segment is directly or indirectly controlled by the marksman, the athlete that is shooting. And it has information about the EST configuration, what target height they should have if the lights are on or off. It defines whether or not how many sighter shots you have, if any. And then like expected number of shots in each stage. That is a range script. All right, so now let's actually turn our attention. This is a technical overview. Let's turn our attention to Visual Studio and a real-world example of how to access the definition files and the information available within a definition file. And I am going to, in this example, continue along with the example of using a 3x20. All right, the code that I have in front of you is part of our Scopos Labs Git repository. Scopos Labs is a series of examples of how to programmingly access Scopos data and how to use the Babelfish NuGet package. And this example is specific for pulling down a course of fire, learning information about that course of fire, and what this example does is print it to the screen. But hopefully, the programmers amongst us can get an idea of how to better use this information in a real-world application. And we are making use of the Babelfish NuGet package. You'll see at the top, I'm pulling in Babelfish, and three different libraries in this example. As I mentioned, to access our definition files, you do have to have a XAPI key. We do have one XAPI key that is purposely listed as an example. It is publicly available, and you can use it in your first day or two. Just keep in mind that because it is publicly available, everybody else is using it as well. It is not meant for a real-world application. It is meant for running these example scripts once or twice, and then hopefully you'll get your own API key. The local start directory, I mentioned the definition cache uses a lot of caching. That includes both file system cache and in-memory cache, so it needs to know where it can place its temporary files. All right. In this particular example, we are going to be looking at the National 3-Position Air Rifle Council Rulebooks 3x20 course of fire, and we see the set name listed, and we are parsing that into a object. In this next line of code, we are actually reading that definition file. The definition cache, if it can't find it in the local store directory, in the local file system, it knows to ask the API to download it. Again, definition cache does it automatically. It is the preferred way to get all of your definition files. All right, once the definition file is pulled down from the REST API, these write lines just pull out some basic information found in the definition file. The common name, description, the discipline, and the subdiscipline. Within this code example, our comments include the expected output as a reference. All right, so now let's do something a bit more interesting with the definition file. Let's find out what events exist in this in this definition. So the definition file itself does distinctly define each event. However, the way that it defines it is really not accessible easily. So we have a method called the grow the event tree. You'll remember the event tree that we showed in the slide deck a few moments ago, and we're basically, our term is growing it. And when we grow the event tree, we make the events a lot more accessible programmatically. And the reality is, almost every time that you pull down a course of fire definition, one of the things you're going to do is grow the event tree to have access to the events. All right, once we have grown the event tree, we can get access to the events. In this case, this little for loop says, give me the events for the stages. And again, a 3x20 has 3 stages: kneeling, prone, and standing. This line of code, programmatically accesses that information. And then we're just going to pull out some information about the stage itself. We're going to print it, the event name, and then we're going to count how many shots each event has. And then these next 2 paragraphs, we're going to look at the recommended result lists for the different stages, as well as the recommended ranking rule for each of the stages. And again, we're just pulling out some information. So we still see we're using the definition cache to get the definition files for both the result list and ranking rules. And again, we're just printing some information about the rules themselves. All right, and then the final example, as I mentioned, course fire definition has 2 big things: the distinct definitions for each event, and it also has the range script. And in this example, we're not going to go into like the timings that might be found or the target heights, but we are just going to print out each of the commands, the little commands that the range officer is going to print. Couple simple for loops. Again, we're going to go through each segment and then each command, and finally print the command to screen. So if we run this example, all right, lots of things printed to the screen. Let's go to the top. So first of all, please note that if you are using that shared API key, it is going to give you a warning. Here's the information about the basic information about the course of fire definition. Then we see that it read the 3 different stages that the course has, and printed out information about the stage, how many shots, and the expected result list and ranking rules for those stages. And then finally, it prints out each command that the range officer says to the athletes. Again, all of this information is coming from the definition file. I can go ahead and close this up. We could do the same thing for any course of fire definition, and without changing a line of code, other than specifying which definition to read, we will find out information about in any of the courses of fire. All right, that's it. That is our example. In summary, definition files define the sport of shooting. It is the standard that we've established to take the concepts printed in a printed rulebook and put them into a form that computers can understand. Definition files drive everything that here at Scopos, whether it's Orion or whether it is Athena or, quite frankly, results. Everything is driven by those definition files. And any programmer wanting to access our data should have a decent understanding of the definition files and how they interact. So with that, please dive in, go for it. Please check out the examples we have on our Scopos Labs Git repository. They're there to help you. If you do have any questions about using definition files or using Babelfish, you can submit a issue within the Babelfish repository. Babelfish, by the way, is open sourced. It's also available on Git. Submit a issue, and one of us will try to respond. So with that, and in the famous words of AWS's Werner Vogel, go build.